Okay, so as an example, let's do this problem. Okay, find the response of the system when the input x of t is equal to e raised to minus 2t u of t and h of t is equal to u of t minus 3. Okay, so here find the response. Response means y of t, right? So here given x of t is equal to e raised to minus 2t u of t and h of t, that is the impulse response, is given by u of t minus 3. Okay, so now I'm going to find the value of y of t, right? Y of t we know it is x of t convolution with h of t, right? But if I'm taking Laplace transform, then this becomes y of s is equal to x of s into h of s. X of s into h of s. So what is x of s? X of s is the Laplace transform of x of t. The Laplace transform x of t. That is the Laplace transform of what is x of t? X of t is given by e raised to minus 2t u of t. This is your x of t. So this is nothing but 1 by s plus 2. So x of s is equal to 1 by s plus 2. Likewise, h of t is u of t minus 3. U of t minus 3. We know that the Laplace transform of u of t is equal to 1 by s, right? Is equal to 1 by s. This is the Laplace transform of u of t, right? So this is u of t minus 3. That means this is a time shifting property, yeah? We apply time shifting to this. So time shift in the time domain means frequency shift in the a time shift in the time domain means exponential function in the frequency domain, right? So that means h of s is nothing but the Laplace transform of h of t, which is the Laplace transform of u of t minus 3, which is nothing but the Laplace transform of e raised to minus 3s, because the time shift is minus 3 seconds, so it will be e raised to minus 3s into 1 by s. 1 by s is the Laplace transform of u of t, right? So e raised to minus 3s by s. So therefore I can say that my y of s is nothing but my x of s into h of s. X of s is 1 by s plus 2 and my h of s is e raised to minus 3s by s. So therefore e raised to minus 3s by s into s plus 2. This is your y of s, right? You see, so now all I need to do is find y of t. And how do I find y of t? By simply applying Laplace inverse to y of s. That means all I have to do is simply apply partial fraction to this. Okay? Partial fraction to this. And here, as you can see, here there is an e raised to minus 3s, right? So e raised to minus 3s means in the final answer, you have to apply minus 3 seconds time shift to every value of t. That means replace every t with t minus 3. That's the meaning of e raised to minus 3s. Okay? So let me write this like this. E raised to minus 3s into 1 by s into s plus 2. So that means all you need to do is find the Laplace inverse of this, right? Find the Laplace inverse of this and then you replace every t with t minus 3. Then only you will find the Laplace transform of y of t, okay? Or let me make this even more simpler. I'll write like this. E raised to minus 3s into, I will change this into y1 of s. Okay, just to make you understand. Okay, e raised to minus 3s into y1 of s, where y1 of s is 1 by s into s plus 2. Okay, so first I will find the Laplace inverse of y1 of s. Okay, so to find the Laplace transform of y1 of s, I will write y1 of s as a by s plus b by s plus 2. B by s plus 2. Okay, then I find the value of a and b. So value of a is if I remove s from here, only 1 by s plus 2 remains. So this will become 1 by s plus 2 and substitute the value of s is equal to 0. So I will get 1 by 2. So the value of A is 1 by 2 and the value of B is, here B, the denominator of B is s plus 2. So it will be, remove s plus 2 from there, only 1 by s remains and replace s with s is equal to minus 2. So you will get minus 1 by 2. Or in other words, y1 of s is 1 by 2s minus 1 by 2 into 1 by s plus 2, right? So this is how we find. So in other words, if I want to take the Laplace inverse of this, so if I'm going to take Laplace inverse of this, then y1 of t is equal to 1 by 2 Laplace inverse of 1 by s minus 1 by 2 Laplace inverse of 1 by s plus 2. Okay, and the Laplace inverse of 1 by s is u of t. So this is nothing but 1 by 2 into u of t minus, and the Laplace transform of this is e raised to minus 2t u of t, minus 1 by 2 e raised to minus 2t u of t. Okay, so now I found. So what is my, but my answer is y of s is equal to e raised to minus 3s into y1 of s, into y1 of s. So therefore my y of t is nothing but my y1 of t when t is replaced by t minus 3. So in the other case, y of t is nothing but 1 by 2 into u of t minus 3 minus 1 by 2 into e raised to minus 2 into t minus 3 into u of t minus 3. See, this is how we solve the answer. Okay, so this is how we do the problem, right? So here if you remember that when you are doing applying convolution theorem using the formula, that is integral y of t is equal to integral x of tau into h of t minus tau, that this problem takes more than 2 pages, right? Because we have to find the every value of u of t and we have to find every range of tau, then we have to apply that every range of tau to every range of t, and then you have to find the equation. Yes. So instead of all that method, if you are using Laplace transform, this problem becomes very easy, right? Because all you need to do is find the value of x of s. You find the value of x of s. Then you find the value of h of s. Then you multiply x of s with h of s. You multiply that, and then after that you find the Laplace inverse of y of s. And then you find the inverse of that y of s. This is how we do every problems in this question. Very easy. Laplace transform makes these kinds of equations and all very easy, right? This is the advantage of Laplace transform. Okay.